The area in question, actually just double check, I'm pretty sure the area in question is this area here.
Yes.
Yep, okay. Now, this is a classic example of the kind of area where, you see how these equations have been given you in kind of an awkward, unusual way? X is the subject. They are functions of y, okay? So clearly what they're kind of encouraging you towards is to integrate this, rather than with respect to x, with this sideways parabola on top and the straight line underneath, they want you to integrate with respect to y, okay? Now I think they give you some values here. I think that's 4, and that's 2, I think. Someone tell me if the number's right? Yeah? Now, I just want to caution you a little bit with this because it might not be what you guess, okay? Because this is an area between two curves. It's an area between two curves. I want to form two integrals, and I want them to be, you know, the higher one take away the lower one. But we're looking at this, and we're looking at it sideways. Now you've got to be really careful, right? Think about it this way. When you look at a normal one, right, which is upright, and you're thinking about everything in terms of x, okay? In this case, we would say the straight line is above, and the parabola is below, right? That's because we have a clear idea of above and below, right? A more rigorous way of defining it is that these x values, sorry, these y values, the ordinates, right, of these numbers here are higher, greater than the ordinates for these points along here, right? Because look, these ones are all pretty much positive, right? A lot of these ones are negative, but the ones that are positive, they're less than, okay? Now the sign is really critical, okay, because that will help you here, whereas above and below are not so reliable. Here's how I know, right? When you have a look at the parabola and the straight line, which one has higher? Now I'm not looking at ordinates anymore, am I? I'm looking, because ordinates are about y values, ups and downs, okay? I'm looking left and right. So which one has higher x values? Higher, greater. And the answer is it's the parabola, right? The parabola will consistently have higher x values than the straight line. Does that make sense? So the way to rotate your head, and this is not that obvious, the way to rotate your head is clockwise, right? This is up. This is up. And that makes sense because if you think about the x-axis, right, you've got 0 and then you go 1, 2, 3, 4, etc. Well, actually, sorry, that should be 2. You get the idea. Numbers are going up that way, okay? So therefore, this is the critical part. The numbers itself take care of themselves. But when you're forming the integral for that area, right, you form, and I'll make a mention of a couple other things here. You form the integral from your y boundaries. So there's the lower one and there's the upper one. I'm going up, okay? You've got your parabola, as it were, on top. That's your higher function, okay? So I'm going to go 5y minus y squared minus 4. And then I subtract the lower function, the one with smaller x values, which is 4 minus y. That's all with respect to y. Okay, is that all right? So this you can see is going to simplify just a little bit. What do we got here? I'm going to put it in order of the powers. So that means my negative y squared should be out the front. How many y's do I have?
6y.
6y, because 5y double negative, so it becomes 6. Minus 4 minus 4, minus 8. Watch out for that one. That's an easy error to make. And then you can go ahead and find the primitive from there. Okay. Now, just a little note. I'm going to skip some of the working because I think you know what to do from here. When you get down to an answer, I'm going to mention this is something I've been actually, honestly, a little bit sloppy with, partly because it doesn't matter if you were that sloppy, but if you want to be really correct, you notice all the way through, right, I've been just dealing with numbers. There are no units here, okay? The answer I get at the end is 1 1/3, okay? Now, so far, I've been doing sort of the quick and dirty way, which most people have also been doing, and say, once you get to the end, you say, okay, now I have units, right? Now, technically speaking, that's not correct because there were never units up here, right? So why should units, a wild unit squared suddenly appear? You really shouldn't do that. The best way, the most correct way to do this is to say this is some number, it's just a number, that's all an integral tells you, and then you make a conclusion. You say, okay, the area is this thing, and that's where the units appear. Okay? Now this is kind of more important as we start looking at other things. For instance, using integration to work out things that aren't areas. We'll just have to wait till the next couple of lessons to find out what those are. Okay? But like I said, I don't think you would ever lose marks for saying units squared here, which is part of why I've been a bit lazy there. But if you want to do it exactly properly, there are no units all the way through. It's just a number. And then you make a concluding statement. Okay. So like I said, be careful when you're integrating with respect to y, because up is not as intuitive as it is when you're integrating with respect to x. But after you've done that, everything is exactly the same. I mean, you know, some of the lines I skipped, the primitive is going to read exactly the same. Minus y cubed on 3 plus 3y squared, right? Because you divided by 2. Minus 8y, and you're going to go from 2 to 4, etc. Okay? So I just wanted to point that out because people often get the integration with respect to y. They often get it wrong because they rotate their heads the wrong way. So just watch out for it. Okay?